We are live.
We are live. Hello and welcome.
Welcome to this final show.
Yeah, it's time for winners announcement. Will be a lot of fun. We have standard part of program, and then we'll dive into the winners announcement as quickly as possible. So.
Yep, my name is Kim Hedberg, and I work as a strategy manager and offering manager at Stratiteq.
And my name is Goran Vukšić. I work as technical manager. So AI for Healthcare Hackathon took place online for 3 weeks. There was a lot of interesting challenges provided by leading hospitals across Europe. We've seen a lot of teams participating. We had 37 submissions, which was really a lot of interesting projects there to look at. People put a lot of effort in it. And yeah, we are happy to announce winners today. So.
Yeah, the hackathon is organized by Microsoft and Stratiteq. And we are helped by these main partners, Nvidia, SAS, and Women in AI. And we are also supported by some partnering hospitals and organizations like Foundation 29, HM Hospitales, Hospital San Raffaele, Sanitas, and University Hospital Basel.
Supporting organizations for this hackathon that help us along the way to share the voice about the hackathons and such are Live AI, Microsoft for Startups, Microsoft Reactor, Faculty of Organization Informatics Croatia, Hackathons Australia, Global AI Student Conference. So, a lot of projects, and how were they judged?
They were judged on these 4 criteria. So impact, how much impact would the solution have in solving the challenges presented, or even more challenges than just the track challenge. Feasibility, is the solution realistic in terms of technical, legal, or other practical aspects? Can it be done? And implementation, how much was done during the hackathon in terms of making real software solution? And then eventually innovation, of course. Is the solution innovative and creative? Is it using the latest technology?
Awesome. And our great council reviewed those projects, and judges voted on them. So thanks to everybody in the council and our judges. All information is on the post over there. You can look into details and also details on the prizes. And we have 3 tracks. We are announcing 3 track winners first. Then we will go into the partner prizes. And we will announce prizes Microsoft for Startups, SAS, and Nvidia. And regarding hospitals and partnering organizations, they will review these projects and reach out to teams after the hackathon. So we have 6 prizes to announce. And track winners, they will get Azure Hero Maker Badge for every team member. They will also receive a digital certificate, and they will have this great opportunity to present their project at innovation track of the next virtual Microsoft Industry Circle. Okay, so shall we start?
We should.
Yeah.
Exciting, exciting.
Yep. So first track.
Yes. So AI applied to medical imaging.
And for that track, we have Veronica from Microsoft to announce the winner. And yeah, let's see that. So.
Good afternoon, everyone. I'm Veronica Jager, Director for Healthcare in Microsoft Western Europe. And today I have the pleasure to announce the winning team for the AI Applied Medical Images category. There are a number of reasons why we selected the team. So let me please list all of them. Number 1, we really liked the technical solution, the solution from a technical perspective. The DenseNet training architecture that the team has chosen, as well as some of the open source frameworks. We also think the solution can be easily extended to other radiology use cases. Additionally, the team has spent quality time in designing the user interface, which is particularly important in healthcare because we need to provide clinicians with easy-to-use tools that will enable them increasing their efficacy and their efficiency. The team is also made up of a very diverse group of people, 7 ladies coming from all over the world with different skills and competencies, showing that multidisciplinary is a key element in health because you need really different skills to tackle the challenges that we have in this industry. There is, of course, some work that needs to be done in terms of compliance, in terms of explainability and interpretability of the algorithm, because we want to help clinicians understand why the algorithm has provided a specific outcome. But you are on a good trajectory, so I'm happy to announce the winner. The winning team is AI Wonder Girl. Congratulations.
We got some comments that voice was off at the beginning of the video. I think that was a small glitch that was just fixed. So I believe you were able to hear that AI Wonder Girls have won the track AI applied to medical images. So yeah, huge congratulations to the
winning team. Yeah.
Yeah, seven ladies from all over the world. Like, it's really nice. Cool. So now we will have a look at the video, what they actually did.
Let's first introduce our team, AI Wonder Girls. We have a look. We are very proud to be an all-women team with a lot of diversity in terms of culture and technical background. We cover a total of 6 countries and have technical expertise on AI and data science, as well as software development and project management. For this project, we divided our work in different parts, as you can see here, covering all the parts of the designing of the solution all the way to the implementation. So let's see how we did this. To start, we first need to understand the problem. So in the recent years, the advances in technology and AI have led to a true boom of AI-driven algorithms for medical applications. Medicine can profit hugely from AI technologies when it comes to automate and speed up manual medical processes. Then such technologies can literally save lives. However, there's still a gap between the many technologies that are currently being developed by addressing medical applications of AI and the use of such technologies by healthcare professionals. Most of those professionals do not necessarily have a technology background and still need to use these technologies. So let's see how we divided our goals for this project.
To address the challenge, we chose to develop a proof-of-concept radiology workflow that communicates the output of the AI algorithm to the doctor or radiologist in a seamless way. Starting from an X-ray, then using AI to classify if a patient has a fracture or not. The tool then translates this AI-driven analysis into relevant medical terms. And this gets communicated to the radiologist via a communication pipeline. Our solution uses standard and open source frameworks demonstrating its feasibility. We built a prototype workflow using an X-ray fracture diagnostic workflow. This prototype can be easily scaled to other medical imaging applications and to other facilities under the same healthcare organization. Our solution can be integrated seamlessly into existing radiology frameworks, easing workflows. It can also save time to results for doctors and patients, and notifies everyone in the process, helping communication.
As for our pipeline, we actually get the batch images, the DICOM images from the PACS database. Then we call our model, trained one, to perform prediction. In our case, it's fracture or no fracture. Then we store all the burns performed on the batches, along with some important details from the DICOM files inside our databases. Then, in the front-end app, we retrieve all the important fields, like, for example, patient ID, exam ID. We expose them for the radiologists, so you can see them. And then each time the inference is ready, or the prediction of the model is ready, we send out notifications to the radiologists, of course, according to the settings they set. As for model training and inference, we use the testnet 121 model trained by using the Monai library. What we do is that we get DICOM images, we actually extract the images from the DICOM files along with some important fields like patient ID, as mentioned before. Then, after we pre-process the image, turn it into a PNG, then we feed it to the trained model to perform the inference and get the final prediction, as in fracture or non-fracture for our case. So we trained the model on 130 images, both left and right hand, and the score we got was approximately 80% in accuracy on the validation set. And the inference time doesn't take long, like just less than 30 seconds on a batch of 8 images.
Here is the demo of the AI medical imaging application user interface. This UI is used for communication of AI model prediction, analytics, configuration, and viewing of reports. Let us go into the configuration page. Here the radiologist can configure the database that holds the DICOM information and the model prediction. Let us select the fields here. We can also select the report fields here, where the AI model generates the report based on these fields. Once the fields are selected, the configuration is saved. Let us go into the dashboard page. The dashboard gives a view of AI pipeline at the backend. You can initiate the batch inference here, and the summary and analytics of the test run are shown here. This is the summary generated by the test run, which is retrieved from the database. All the fields that we have selected for the database are being displayed here. So the fracture prediction is what is the data that comes from the AI model. These are the visualizations of the summary. Let us go into the reports page. Here the reports that are generated by the AI inference engine can be viewed here. We select the patient ID and retrieve the examination, the report of the examination which is generated by the AI engine. Here is the report generated by the AI engine. These are all the fields that we have selected in the configuration of the report. We can also download the report from this page as a PDF document, which can be further sent to the clinicians.
We also built a communication design to channel communication between radiologist and AI application. It works by sending notification for critical cases through mobile, SMS, email, desktop, and mobile application messages. In case of critical emergency cases, the channel communicates to on-duty officers, alerting the radiologist towards urgent cases. To visualize the prototype, we have designed a desktop application prototype, tracked and triggered. The application starts with user registration to allow them to view generated reports, which can be edited, saved, or downloaded. The report edited option allows radiologists to compare actual X-ray with heat map image and make a final comment on fractured image before downloading. A dashboard is also available in application for generating graphical customizable summary of records. The last and important part of application is sending notification. As we discussed earlier, notifications are crucial for prioritizing critical cases.
We have challenges such as understanding the medical knowledge for classifying what is a fracture so that the model can be trained accurately. For that, we had constant communication with medical experts. We also worked on building an innovative application that is adaptable and can provide information to doctors via multiple devices. Finally, we cared about data privacy by using anonymized data.
This is a contribution within healthcare operations, specifically going from model POC to deployment. It helps save the doctor's time that they can use to treat patients more quickly and efficiently by using this workflow. As we know, the best model is the one that is used in real life.
Perfect, impressive.
Yeah, totally great.
Yeah.
Interesting project, great team, and congratulations once again. So, next track, predictive medicine. Winner will be announced by our CEO, Stratiteq CEO, Frank Hennekens. And
hello.
We have Frank on the screen. Hello.
Hello.
So
now we have you back on the screen. Yeah. Perfect.
It works.
Now it works at least.
Yeah, exactly.
And here to stay, I hope.
Yes, we hope so too.
Okay, Frank, so
over to you.
All right. Well, thanks for the introduction. Frank, my name, CEO for Stratiteq, as said. And first off, and know that I'm being biased, but thank you, Kim and Goran, for hosting this hackathon and the way you're doing it. Fantastic, fantastic job. And I just have to say that as Stratiteq, I can only say that we're really, really thankful to having been able to execute this hackathon together with such great partners as Microsoft, as Nvidia, Women in AI, and SES. So really, really great. So then on to, I guess, the actual hackathon contributions. And it's just been a great joy to see the engagement of so many in this hackathon in truly global teams. Really impressive. And the presentations of the team show that all participants have put a lot of thought and thinking and heads into this, but above all show the passion for it all and really put their hearts into this. So for the track Predictive Medicine, the jury came up with the following remarks. A lot of great ideas with promising direction, massive potential impact, and good examples on how they have used data sets to prove this. The UI demo is easy for healthcare providers to understand and use. I can see the solution being used in other healthcare use cases to help clinicians save more lives and reduce malpractice errors. And as a last comment, great enthusiasm in the video. So with these words of the jury, the winner of the track Predictive Medicine is Analysis Mode, Predictive Medicine. Congratulations.
Congratulations to the winner.
So we can take a look at the video.
Yep.
Milda from Analysis Mode here. We are on the Predictive Medicine track. By the way, greetings from Finland. So our objective is to obtain a predictive model of patient response to the treatments applied to them, taking into consideration the sociodemographic data. So the problem we see is that the normal medicine treats all patients exactly the same. What we want to do is we want to look at the data provided by the hospitals and see what treatment works for which group of the patients. So what we did, we initially selected 38 features which makes biological sense to predict treatment efficacy. In the beginning, to be honest, we had no idea what was going on because we got so much data, but then we sat down with the team and we agreed what would make the biggest impact, and we agreed to work on the treatment efficacy. And then we came up with clear 11 steps.
The time we had, we decided to start with a basic stack of data science. So we're using Pandas, Google Colab to share the code, scikit-learn, and NumPy. And in terms of algorithm, we decided to go with a neural evolution. So we could actually see how the model would evolve over time and easier for us to understand because it was new data for us as well. We picked the first, second, and fourth data. So first was about the patient demographics and temperature checks and just the basic diagnostic. Second was the drugs that were recommended and actually given to that patient and the amount of doses and so on. And fourth, we had lab results, blood tests, and so on.
We consider age to be one of the most important factors when it comes to prediction for COVID-19. Then we have the second data set, CGCell2, with all the rows that are agua in the column ITC7 name that are not necessary, not crucial at all. And also all the rows with values in this list that you can see on the screen, a very long list. We encountered another problem, which was the drug type and the drug concentration might or were different in some cases, but they have the same ID. That is MET7. This is an information extraction model for clinical NLP. So here's the example output as a raw code and the beautiful version generated by the code I just mentioned for the color labeling. So you can see here every information is extracted. We're able to transform the column drug commissioning into two other columns, strength and drug.
So we did a quick model run into this, and we managed to have 94% accuracy into this prediction. So we're able to figure out if the patient was going to die with that existing treatment or not. So it was very good to start with this. And by looking at this model, we are able to also explain. So when you look at the first order of importance, the average dose administered is the most important. Then you have the patient's age, and then you have the blood pressure. Then the second importance, we have the temperature. The first one is checked in emergency, and the oxygen saturation. And they have specific ranges that they should be in between. So healthcare professionals can already read this and understand what is important for this prediction of the AI. Also, we found out that there is a bit of a data set imbalance. So that's something we need to work further with the hospital.
We can see diagnosed conditions from the patients. And using this information, we can connect the diagnosed conditions to risk factors with COVID, such as hypoglycemia could indicate diabetes, palpitations, chest pains, arterial hypertension, and tachycardia could indicate a heart condition, while tumorization and oncological patient impairment implies that the patient has cancer. Now, these risk factors for COVID weigh heavily on predicting patient mortality.
And while the methods were very helpful, we learned a lot. First, they helped us to understand what is the value on the prediction of the patient if it had a death or a transfer or if it was sent at home and so on. So we figured out which one can be considered as a healed patient, which was quite difficult at first. And one tricky thing was, when you say the patient was transferred, could this patient actually end up in a death? Yeah, actually sometimes the hospital might actually lose track of the patient and doesn't know the end outcome of the patient. So this was great to talk with professionals. Also, we also assume if the patient was healed based on the transfer. Perhaps transferring to a different hospital would increase the patient's chances. So all these kind of things we had to consider, and the mentors were very helpful.
The data sets contain a large number of black results, but which ones are the most relevant? Specifically, which ones are the most relevant for COVID diagnostics, risk group assessment, and choosing the right treatment/drug? You can look at leukocytes, which would be an indication of inflammation, as well as the body fighting off infection. You can also look at oxygen saturation, so PO2 and SO2C. And this would tell you if a patient would have to be put on a ventilator or not, depending on how their blood oxygen levels are.
We got a really good result. We got one model in which can solve 3 use cases. So first one, by looking at the patient demographics plus the drugs taken, we can predict the treatment efficacy of that combination. Second, by looking at the patient demographics plus a target efficiency treatment, we can recommend which drugs shall be given to achieve that target. Also, we can also get the drugs inventory of the hospital plus the target efficiency of the treatment and predict which group of patients can be served the best with those drugs and that target.
Machine learning is hard to use, but we created a simple interface because have you ever wondered if this treatment will work for the particular patient? Right now, you, a healthcare professional, can just input the info of the patient and put what kind of treatment would you like to use, and then with one click of the button, you will get the treatment efficacy. We collected the team from 5 different countries with expertise in healthcare, tech, and business to bring this to you. Our next steps are very clear, and we are ready for our first pilot project. Thank you so much.
Great.
Thank you, Analysis Mode, and congratulations. Really impressive project. Okay, so last track,
Exactly.
number 3, empower patients. So we got some nice comments on that one also.
Yep.
One of the comments was great idea, clear description of motivation.
Yeah, it's a great opportunity for patients with rare diseases to connect and get into the shared area to exchange their experiences. I would love to see how you're getting feedback from patients on your app and then deploying it. Good luck. That's from the jury, of course. So this is the track for Empower Patients.
Yeah, and the winner is?
The winner is Cared. I don't know how they want to pronounce, but Cared, Care for Rare Diseases.
Yeah.
So congratulations.
Let's see the video.
Hello everyone. Our team chose to tackle the Empower Patients track. Here is our product, Cared app, a personalized health hub tailored especially for patients suffering from rare diseases. Did you know that there's a 1 in 10 chance you know someone who has a rare disease? They often face devastating medical problems and symptoms, difficulty getting a clear diagnosis, limited availability of their condition, limited or no treatment options, and feeling alone or isolated. This economic burden has cost the U.S. nearly $1 trillion in 2019, according to the Everyday Life Foundation for Rare Disease Study, as you can see on the slide. As a group, our work started with a discovery process by analyzing rare disease social groups on Facebook in order to really understand what their pain points are. This quote came up: when you have a rare disease, you face two battles, one being the illness itself and the other living in a world where so few people understand what you're up. Our research also showed that patients with rare chronic disease often struggle to know if the symptoms they are facing are due to the illness they live with or are temporary. However, it is difficult for them to go to the doctor for each new symptom, especially in the case of chronic rare diseases. Thus, they look for peers experiencing similar symptoms to reassure themselves and together look for ways to relieve the symptoms. This slide shows quotes from some of the patients. This inspired us as a team to develop a personalized platform tailored to patients diagnosed with rare diseases and their loved ones. Cared is a patient-centered app providing a safe space for patients to connect with others and to easily access trustworthy and up-to-date medical information. This will also help engage patients to be proactive in their care. We also aim to create an awareness about rare diseases to help improve quality of life and possibly could save lives. We conducted our market analysis, and here are the existing players in this area. TeamScope, FlareDown, Simple, Care Clinic. These 4 apps all offer symptom tracking for patients. Their features and unique selling points are outlined here. The features that we have that they do not have are real-time patient matching based on symptom history, empowering patients by providing them with tailored articles from reliable resources, and we are also a rare disease-specific platform. For now, we have 3 main features, namely symptom tracking, connecting with other patients, and research feature by providing education and reliable, trustworthy resources. Under tracking feature, we're hoping to capture patient-reported information such as symptoms and their frequency. And this data that our users will be inputting will be stored in a safe and secure HIPAA-compliant cloud API. Depending on the user's preference, users will be able to have insights from their data in a form of summary. Next is the meeting or the connecting feature. It's a community social support to provide a safe space to the patients and their loved ones. And we aim to connect and match patients to other patients that have similar symptoms and diagnoses. This will also allow a dialogue to be created around certain topics impacting the rare disease community and empower patients to feel comfortable and confident sharing their stories. And lastly, the resources feature. We also understand the concerns over misinformation online. So one of our features is to provide an instant access to trustworthy health information resources that is fact-checked by our. And here's the backend algorithms for analytics. Under track feature, we'll be creating individual user database and integrate them with the main server data. Under connect feature, we will be using a popular AI matching algorithm to match a new user to either individual facing similar symptoms or connecting them to the individuals that have shown similar symptoms historically. And under resource feature, will contain a resource database continuously updated based on the community needs. And here is our prototype of our Cared app using Figma. And for our next steps in the future, we would like to collaborate with existing community organizations related to rare disease, since community partners are already in place. We are hoping that our platform will act as a support system to the existing programs or organizations such as the Radar Card and RDCR. And we also intend to add a chatbot application that provides proactive check-ins and just-in-time resources based on the user's emotional state and needs using natural language processing. And for further data protection measures, we intend to protect patients' data with an encryption. So our team is comprised of diverse backgrounds, and I hope you join our mission to empower and connect patients and make communication and medical information accessible and inclusive. Thanks for your attention.
Wow, an
Great.
additional one.
Yeah, really inspiring and empowering patients. So really great idea and application. So those were the track winners, and we are getting to the more exciting part. But before that,
we need to
celebrate. We need to celebrate a bit.
Congratulations to all the track winners.
Yes, as the track winners, as we said earlier, you won some nice prizes. So you got the digital badge, Azure Heroes Maker badge for every team member. You will receive a digital certificate that you are a track winner, and you will have opportunity to present at innovation track of next virtual Microsoft Industry Circle. This is really a great thing for the teams to show their projects.
Yep.
Okay, so getting to the partner prizes, which is interesting. As we said, hospitals will reach after the hackathon and to the teams that worked on their data. What we announced today is partner prizes from Microsoft, from startups, Nvidia, and SAS. And first we have Microsoft for startups. I believe Kelvin will join us in the studio.
Hello.
Hi everyone, how's it going?
It's fine.
It's going great.
Fantastic, great to be back again after, I think it was last week that we talked about the Microsoft for Stars program, how to apply the benefits, everything like that. Yep. So, you know, a lot of water has flown under the bridge, a lot of great projects have come through, and I think, you know, us at Microsoft for Stars, we've been so privileged to be part of this hackathon. We've been very, very keen to see some of the projects that have come through as part of the hackathon, and I guess where we are now is the all-important bit, and you know, the difficult bit, I guess, of finding a winner and finding just one to bring onto the program. And I guess, you know, myself and Andrew McAdam, global field lead from Microsoft for Startups, who was actually part of the judging panel for this hackathon. We've had a lengthy discussion over the last number of days around who we thought would be best suited to the program at the moment. And you know, there was a lot of projects there that, you know, hopefully we'll see on the Microsoft Stars program in the future. But one really stood out in terms of, you know, one that hit a global problem, one that seemed to be really solving that global problem at the moment, or very close to solving it, and one, I guess, that really had put in a spectacular level of sort of visualization of the problem and the potential solution to that problem. Okay, and I think, you know, the way that we sort of judged this and the way that we wanted to to position ourselves is that it was a very disruptive technology, one that was can potentially be implemented quite soon, and one I think that we as Microsoft for Startups could offer a significant amount of resource to when they came onto the program. So the winner of the Microsoft for Startups prize, and one that we hope to be welcoming onto the program quite soon, is carotid plaque risk assessment. So congratulations to you. Looking forward to having you on the program and looking forward to helping you scale and grow on our technology and really achieve the goals that you want to do.
Congratulations and thank you, Calvin. Yeah, we will have a look at the carotid video.
Thank you.
Hello and welcome to this presentation. My name is Branislav Hollander and I am part of the Pure Imaging team. For this hackathon, we decided to work on carotid plaque risk assessment using ultrasound videos. Let me shortly introduce you to the structure of the presentation. First, I will present the clinical problem statement. Then I will go over our proposed solution. I will also give a demo of our solution. And finally, I will spend some seconds on our team. Stroke is a dangerous clinical condition, killing or permanently disabling around 10 million people per year, while also being very costly to treat. Stroke is closely related to carotid plaque. Currently, preventive stroke screening is not recommended due to the unreliability or even harmfulness of screening methods such as ultrasound flow imaging or CT angiography. On the other hand, three-dimensional tomographic ultrasound has proven to be an accurate and precise tool to predict carotid plaque. It's also found its way into various recommendations. We propose a fully automatic software for plaque risk assessment in ultrasound videos. We accomplish this by reconstructing a 3D volume from the ultrasound video and segmenting the plaque from the volume. We also extract clinically relevant parameters such as plaque volume or 3D grayscale median, which are both closely correlated with the risk of stroke. Due to being fully automatic, the software may also be used by less experienced sonographers in private clinics or hospitals. We faced a couple of challenges during this hackathon. First of all, there are no open annotated datasets available for this problem, and the annotation process is expensive and time-consuming, due to which we only had access to an annotated dataset of 30 patients. On the other hand, we also had access to an unlabeled dataset of 150 patients, acquired with a multitude of probes, post-processing methods, and different ultrasound machines. We leveraged the large unlabeled dataset by training a generative adversarial network to generate further synthetic ultrasound images, shown on the left. We then used both the real and the generated data for a self-supervised pre-training of a segmentation network. To perform the pre-training, we corrupted ultrasound images with various transformations and tried to reconstruct the origin. The result of the reconstruction is shown in the middle column. We also performed domain transfer from the annotated dataset to the unlabeled dataset using a different generative adversarial network. This allowed us to generate new synthetic images with the same label maps as the annotated dataset. We then trained the pre-trained segmentation network with the annotated dataset plus the synthetic annotated dataset and integrated the final model into a Windows application. Let me now give you a short demo of our application. So here we are in the plaque segmentation app. This app was specifically developed for this hackathon, and it mainly consists of 4 views. The upper left view is the 3D rendering of the ultrasound volume, whereas This is the transverse, the sagittal, and the coronal view of the ultrasound volume. We can also scroll through the volume like this, as well as manipulate the NPR planes, as you may be used to from DICOM viewers with CT or MRI volumes. Let us now start the plaque analysis. What this does is it runs the segmentation model that we've developed for the hackathon, and it runs over every ultrasound frame by frame, and it also considers the previous and the next frame of the video. So this should be finished in a couple of seconds. All right, so here we have the result. This is the result visualized in the 3D view. The red color designates the plaque, while the blue color stands for the lumen of the carotid. And we can also scroll through the volume in the NPR planes to inspect the segmentation result. Let us now rotate the NPR planes such that we get a better view of the segmentation itself. Maybe like this. So what you can see here is the carotid. This is the common carotid artery, while this is one branch of the carotid. There is another branch here, which branches off the common carotid artery, but this one is not segmented, and this is due to the annotated data that we've got only having segmented one branch of the carotid artery. So the model, of course, behaves correspondingly. On the right-hand side, we can also see two important clinical parameters. One is the plaque volume, which is calculated from the segmentation. In this case, it is approximately 2.1 cubic centimeters, as well as the normalized grayscale median. This is a parameter, a measurement that is correlated with the risk of stroke in carotid plaque screening. So it gives us a clinically important value for the diagnosis. To conclude, let me shortly present you our team. And thank you for your attention.
Again, it's impressive what we are able to do with technology now.
Yeah, really nice solution, and congratulations once again for this prize from Microsoft for startups. Moving on, we have also prize from Nvidia, and that prize is Expedited Access to Nvidia Inception, an acceleration platform for AI, data science, and HPC startups. There are some program terms that apply, of course, and let's take a look at video from Rob Brisk. We had Rob in one of the streams giving great overview of different tools and frameworks available out there. So let's see video from Rob.
Hi everyone, Rob here from Nvidia. So I had a fantastic time looking through all the entries to this hackathon. I thought the teams did a great job. Some really nice, innovative ideas in the clinical AI domain. And it was great to see. The team that we've chosen as the Nvidia Prize winner is the AI Wonder Girls. The AI Wonder Girls trained an AI model to do fracture detection from wrist x-rays, but they also then packaged up the model into a really nice holistic application that thought about how the findings of the AI model were delivered into the clinical environment. And so for that reason, we felt that they took a more holistic approach than some of the other projects and really stood out. So Congratulations to the AI Wonder Girls, congratulations to all the teams in this hackathon, and I really look forward to seeing where all the connections made and the ideas had during this undertaking go.
Great, so congratulations to AI Wonder Girls.
Yeah, they are not just a track winner for AI applied to medical imaging, they also won the Nvidia prize. And the last prize for today is from SAS, and that prize is 1 hour virtual meeting with SAS to discuss your project and to get an overview of SAS Vector Labs. So after the hackathon, your team can earn an opportunity to participate with the newest innovation hub, SAS Vector Labs, to further prepare your application for the marketplace. So
let's show the video with Mark Lambrecht.
Hello, I'm Mark Lambrecht with the Health and Life Sciences team at SAS, the global leader in analytics, and it is our mission to improve patient lives with the power of analytics. And this was exactly what this hackathon was about. First of all, I'd like to thank the co-hosts of this hackathon, in particular Microsoft, but also Nvidia, Stratiteq, and Women in AI. It was a true prerogative to be a jury member and very energizing to see the application of AI and interdisciplinary domain knowledge from the different teams. Well done to everyone who participated. And with this, I will be announcing the winner of the SAS prize, and that is Butterfly Data. Congratulations to the team of Butterfly Data with their submission to predict short and long-term stay of patients in hospitals based on a different amount of data sets and variables. A very powerful submission and great visual analytics and the use of SAS analytics, dashboards and models to predict the fate of patients. A truly excellent way to look at clinical practice and bring it one step further and usable in a hospital environment. Congratulations as well to all the other winners of the prizes, and I hope you enjoy this award ceremony. Bye-bye.
Thank you.
Thank you, Mark. Yeah, congratulations to Team Butterfly, and we can take a look at video.
Yes.
Hi, I'm Sarah Botman from Butterfly Data. We have a talented and diverse team at Butterfly Data, but we added to that team by inviting Peter Carrasco to join us. One thing that I think makes Butterfly Data unique is our experience of working with social media data. In this case, it was a lot more interesting to look at the tweets in Spain as the pandemic unfolded, to see what kind of things people were talking about. The lockdown was particularly hard, and were people protesting about that? In many places there were school closures and increased social distancing measures. Butterfly Data has been a SAS partner for many years. I've been using SAS myself since 2003, and it's still my go-to tool for doing that initial data exploration and data cleaning when you need to be able to join different data sources together. This challenge has provided anonymized real-world data about thousands of COVID patients. It's been made available to us purely for the purposes of this hackathon. But I think that this is a fantastic first step in sharing data across Europe and across institutions to help data scientists to understand the trends and the patterns within the data and perhaps even influence what decisions are made about treatment. I know it sounds brutal, but in a situation where your healthcare system is overwhelmed and you only have enough oxygen or ventilators for a certain number of people, using real-world patient data to risk stratify patient groups, whether that's by demographics, by comorbidities, by their current vital signs, is absolutely vital to prioritise treatment. If the healthcare system is overwhelmed, the sad fact is there may not be enough hospital beds, enough ventilators, or enough oxygen for everyone. And it's as well to be able to triage those patients so that you get the best overall outcome. In the early days of the pandemic, SAS produced a COVID-19 dashboard using visual analytics, showing how the pandemic had unfolded across the world, from its beginnings in Wuhan, China, as it spread through Italy and Europe. Spain was particularly badly affected. We can see, as the time slider moves to the right, as we move through April and May, different parts of Spain experienced an increasing number of COVID cases and sadly COVID deaths. The data set that we've been given covers the period from April 2020 to November 2020. Our first task was to get to grips with the data we were seeing. We have patient admission times, vital signs such as heart rate, temperature, oxygen saturation. We have information about whether or not the patient was admitted to the ICU or not, and how long they spent there, what medication they were given, and what their final diagnosis was. Combining all this data together in SAS, we've been able to produce a dashboard and a predictive model so that we can take data from patients when they're admitted and predict whether or not they're likely to subsequently be moved to the intensive care unit and whether or not their case is likely to worsen. We've attempted to predict which patients are likely to stay in hospital for more than 5 days and which patients are likely to die.
So throughout our initial discovery, we wanted to know the spread of ages of all the patients for which we had data. And on top of that, the proportion of males and females across those same ages. We've got a bar chart here with on the y-axis the frequency of those patients across each age, and across the x-axis all of those ages. You can see the letters H and M, they refer to hombres and mujeres. So subsequent discovery of the data. This is a representation of each individual across the 6 sets. What's nice about this visualization here is that you can see quite clearly when the data was collected. So we've got a high proportion of individuals admitted for the duration between March and June of 2020. We've got very few people throughout July. And we can see blood sugar levels here, O2 saturation, heart rate, systolic pressure, and diastolic pressure. Obviously, the blood pressures are normally found in the same result there. I've also created some button bars on this dashboard. So in particular, I wanted to be able to split up the ages according to categories. So not individual ages, but I've split them up 0 to 18, 18 to 30, 30 to 45, and so on. And what I've also got in the top left is a split between those individuals that have been discharged for successful reasons. Maybe that was voluntary, but otherwise they walked out of the hospital, and otherwise deceased. So if we now look at short versus long term, with initially the spread of patients across their relative number of days they spent in hospital. Some people were admitted and discharged within 3 or 4 days. And we've got data on individuals that stayed up to 131 days in hospital. On the left here is a term split. This allows the user to adjust the time or the relative number of days in hospital up to which a person can be recorded as a short-term patient as opposed to a long-term patient. In the line chart at the bottom, I am showing median value of the result from that specific test. So you can test it again, and you can scroll through the test to the bottom of the page. And it's showing the difference between a short-term patient and a long-term patient, just for those first 2 days. And ultimately, we would like to be in a position where we can gather insights from the first 2 days of anyone's stay in hospital for use in a prediction as to whether they will be a short or a long-term patient going forward, and other things in turn.
The concept of this use case is to offer a program that can inform clinical staff if the patient's early hospital data suggests they are likely to be a short or long stay patient. The data we're using is from March to November 2020. Since then, COVID patient care and medication has changed. If an up-to-date database is used, we can give a more accurate assessment of whether the patient is likely to be a short or long stay patient.
So impressive.
Yeah, impressive. Congratulations. 6 prizes to 5 awesome teams and projects.
Yeah.
As we said, we had 37 submissions. Yeah, it was a lot of projects to go through for our council and for the judges to select the best.
Yeah.
Yeah, amazing results.
Yeah, I don't think we should forget either. I mean, we've seen great results. We've had a lot of discussions. I mean, it's been really interesting to hear how far AI has come within hospitals already. I think it's been very interesting to see and hear about the collaboration, because just as Veronica was saying from Microsoft in the beginning, just being able to meet together and collaborate around this is just one step further ahead of using the data we actually have to make healthcare with the help of AI be better in the future. So I think there are lots of wins just outside these submissions as well.
Definitely.
So I feel really proud of being part of this hackathon. I think
it is awesome.
It's cool to see that we
really great.
Yeah.
Short practical info, like soon we will mark the projects on the dev post and announce that, so you can see over there who the winners are. Project gallery will become publicly visible, so you can check out all the other projects, what they did, and yeah, a lot of great stuff there.
Yeah.
Unfortunately, not everybody can win, but we've seen amazing projects there, and yeah, we will follow up with digital certificate and your Azure Hero badge the next week. And keep in mind, there are 2 more prizes from the hospitals. If you worked with their data, they could reach out to you directly in the next week or 2, approximately. Yeah. So, yeah, are we shooting one more?
Yes, we are. We have to shoot and celebrate that it's finished.
Woo! So once again, congratulations to everybody. It was great, a lot of fun, a lot of discussions on Discord, a lot of chats with mentors. Yeah, we had 2 initial panels that were awesome, really spoke about real problems out there and many projects here tackling the real problems. And
so thank you for participating and taking your time and your brains to help solve the big challenges.
Yeah.
And we hope to see you in future hackathons again.
Yeah. Thank you.
Thank you. Bye-bye.
Bye.